Okay, look at this one.
That's how it goes in this movie.
We're going over 5-1. So a lot of these words are words that we've already looked at. Okay, so this first one is called the perpendicular bisector theorem. So review, what does it mean to be perpendicular?
Perpendicular.
Well, if it meant parallel, why didn't they say parallel?
Ooh!
It's not parallel. Perpendicular.
Equal to.
Same degrees, but
They're equal to. I don't know, it's been a while.
I know, that's why I started here.
they cross. No, that's intersection.
It's been 2 weeks.
Parallel. What does parallel mean? 'Cause that's what y'all want to say.
Side each other.
Parallel means
Equal.
their lines look like this. They never cross. Those are parallel lines.
Perpendicular cross.
Perpendicular do cross. And not only do they cross, how do they cross? At a 90-degree angle. Absolutely. Perpendicular lines form a 90-degree angle where they intersect. So if we're talking about perpendicular, that means they cross and form 90-degree angles. What does bisector mean? Bisect.
They bisect. Two angles intersect.
What does bisect mean?
Bi is two. Sec is intersect.
But how do they intersect? They do intersect, but they intersect in a special way. See how I told y'all vocabulary is important? Yeah.
Yes, sir.
Bisect. You know how many times I've written bisect up here?
Oh, why?
Several. And I have to explain it every time.
It's going to be in the beach.
Let me take a gander.
Cuts it into equal pieces. So if I have a line segment that is being bisected, then that means where it crosses, it draws two equal pieces. So AB and BC are the same measure. That's what bisect means. Cuts into two equal pieces. You can bisect line segments, or you could bisect angles. Right? If I had an angle here, and then I had an angle bisector, it cuts the angle into two smaller equivalent pieces. So if we have a perpendicular 90-degree bisector, two equal pieces, theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So what it says here, we draw PQ. PQ is a perpendicular bisector. What that means is what that means is P to X is the same length as P to Y. Alright, that's the new theorem, the perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segments. So, well, how do we know that these are equivalent? Well, think back to our triangles. Can I say that these two triangles are congruent? By side, angle, side. Side, angle, side. So because the triangles are congruent, then each part is also congruent.
Please. You've received an email. If you don't care to check your email at this time with some important information, please check your email.
Hey, you ready for the email?
Virtual. We're going virtual tomorrow.
Okay.
Hey, go coach it. Oh,
Man, he's really determined.
hey, bust it down. Hey. We're
What is
virtual.
it? What is it? What is it? Tell us, tell us.
Uno reverse. Uno reverse. Nah, he's like, okay.
So, next, 5.2. The converse of the perpendicular bisector theorem. This is what it says. It says if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segments. So because I know that these two are congruent, so what does this look like now? This looks like an isosceles triangle, because I have these two line segments that are Congruent, right? Good notes? Yeah, exactly. So, because it's isosceles, then what that tells me is x cubed is equivalent to y cubed. And it tells me that these are perpendicular. So really it's just going the exact opposite way from the previous.
Hey, that's my middle name.
Wants to park his ice cream cart on Main Street so that he is equidistant from the entrances of the amusement park and the zoo. Where should Mr. Lee park, and how can he determine where to park?
In the zoo entrance.
He wants to be equidistant from the zoo entrance and the park entrance. So how can he figure out where the middle is? So here's what we're going to do. We're going to label the two entrances. So let's pretend like we have a point here at the zoo entrance, and we have a point here at the park entrance. All right. If I draw a straight line,
Then draw a line to the middle of that.
from the zoo to the park, and then in order to find a perpendicular bisector, do you guys remember we did this earlier with a compass where we had to draw out? And so what we would do is we would take this point and we would draw a circle. We would take this point, we would draw a circle, right? And then the point where they intersect would be where he needs to put his ice cream truck. Okay? Okay, so here is what we're looking at. It says, what is the value of AD? So in the end, we want to know this distance from A to D. Okay, so what do I see? Well, I see that BC is congruent to CD. They're both 11. So that means that this line is a perpendicular bisector. What we just learned, perpendicular bisector theorem, means that these two side lengths are congruent. They're equal. So what we're going to do is set those two equal to each other. 6x minus 10 has to equal
3x plus 2.
3x plus 2. And we solve.
Take 2 away.
So I would subtract 3x first. You could do that, but I would get it to be single x first. So that's 3x minus 10 equals 2. Then I would add 10.
12. 3x equals 12.
3x equals 12.
Divide that and you get 4.
Divide by 3.
X equals 2.
X equals 4. Now does it ask me what x equals? Is that the question? No. The question is, what's the value of AD? So in order to find this distance, I'm going to plug 4 in to x. So that would give me 3 times 4
14.
plus 2, which is 14. Okay, so when we look at 4a, okay, how did you get 13?
I did 5n minus 2 equals 2n plus 7.
Okay, and we know that those are equal because this line is a perpendicular bisector, because these two sides are equal. So that means that these two segments are also equal, perpendicular bisector. So we set them equal. And then solve. Subtract 2n. So that should tell me 3n minus 2 equals 7. I would add 2, which tells me 3n equals 9. Then I would divide by 3. That tells me n is 3. Is that the question though?
No.
No.
Plug that into 2.
Plug that in here, right, to find wi. So it would be 2 times 3 plus 7, which is 6 plus 7, which does give 13. Any questions there on 4a? Okay, look at 4b.
Easy, easy.
It is. It is definitely a little bit more challenging. So what I would do, let's look at this big triangle first. Okay, so look, because both of these are 17, then that means that KN is a perpendicular bisector. That means it's going to cut JL into two equal pieces. So do we know what J to N is? 14. So do we know what N to L is? We do. It's also 14 because it's a perpendicular bisector. So I know this entire distance is 14. Okay? Does everybody see where I got that from? N to L is 14. Now look at the smaller triangle. What can I say about it? I have another perpendicular bisector, right? Because both of these are 9. So that means it's going to cut this 14 into two equal pieces, which means from N to M is going to be 7, and from there to L is also going to be 7. So when it asks me for the value of OL, the value there is going to be 7. So basically you had to use the rule twice. The perpendicular bisector theorem used twice. It's side lengths, right? I told you bisect. What does bisect mean? It cuts it into two equal pieces. So we were dealing with segment bisectors, where it was cutting line segments into two equal pieces.
Angle bisectors.
So what's that going to do?
Cut angles in half.
Cut angles into two equal pieces. So the angle bisector theorem says if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So right here, how D is a point that's on the angle bisector, because AD is an angle bisector. Then because D is a point on that line, D is equidistant from B and from C. Equidistant from B and C. So that's what it tells me here is BD is congruent to DC. And then the converse of that, which means going in the opposite direction. So this means if I have a point that is equidistant from two sides of the angles, so you see how I have equidistant, equidistant, then that tells me that this angle A is being bisected into two equal pieces. So it tells me that BAD is congruent to CAD. So again, very similar to how the other bisector theorem worked. Okay, so this one starts off, what is the value of segment KL? The value of segment KL. Okay, when we look, notice how angle J is being bisected. Do you see the two tick marks? So this angle and this angle are congruent. So that means that LJ here is an angle bisector. So because this is an angle bisector, that means these two segments have to be congruent. So 2x plus 3 is equal to 4x minus 11. And then solve. So I would subtract 2x. 3 equals 2x minus 11. Now I have a single x, so let's get that x by itself. So I add 11. It's going to tell me 14 equals 2x. Divide by 2. X equals 7. Could it ask me what x was? No, it asked me for KL. So I'm going to take this 7 and plug it in here to find the distance of KL.
17.
2 times 7 plus 3 is going to be 17. Okay, so if I work the first one, this is how we need to label it. It tells me from H to I is 7, and it tells me from I to J is 7. So that means that's an angle bisector, right? The next thing it tells me the measure of angle HGI is 25. So that means the small one from H to G to I is 25 here. Then it asks me, what's the measure of IGJ? So we want to know, what is the measure of this angle?
7.
It's what?
I said 7.
It's not going to be 7, right? Look here, this line, because these two segments are equal and are 7, that means that this is an angle bisector, which means it cuts big angle G into two smaller equal angles.
Oh, it's 450. 25.
So that smaller angle would also be 25. Right? The entire angle would be 50. From H to G to J. That's why I have to read it. What is it asking for? It's saying from I to G to J. So it's looking for that smaller one, which would also be 25. Okay? So again, the whole point here, take the information and label it. I know that y'all don't like drawing, but it's going to make it so much easier if you draw it out and label it correctly. All right? If I look at B part now, I'm getting there. So B part starts with new information. It tells me H, G, J. So from H to G to J is 57. Okay, then it tells me from I to G to J, that angle is 28.5. Okay, so let's think through this again. So the entire angle is 57. It tells me that this smaller part is 28.5. So can I find this smaller angle? I could. If the whole thing's 57, I could do 57 minus 28.5. And that will tell me the yellow piece, which is also 28.5. So that means that what? This is an angle bisector. It cut into two equal pieces. So because I know it's an angle bisector, then that means that these two lines are the same. So that tells me H to I is 12.2. And it wants to know what is I to J. It's also 12.2.
What's the whole thing again? 57?
Yes.
That equals 24.4. Together? Would you add?
No.
No.
No. The entire angle was 57. Sorry. This smaller piece that's in black here was 28.5. So basically, if I'm trying to find the black plus the yellow has to equal the red. So I would do the red minus the black. The two smaller add to be the larger.